Hello and welcome to the Citizen Science Training Modules. I'm Dr. Chuck Higgins from Middle Tennessee State University and the Radio Jove Project. Radio Jove collaborates with the Sunrise Project to bring you these training modules. We acknowledge our contributors below as well as our funding sources. This is Training Module 0.0, Introduction to the Sun. The prerequisite for these training modules are basic high school level general science, a knowledge of the electromagnetic spectrum, and graphical interpretation of data. The learning objectives for this module are to locate the sun in the sky and learn some basic properties of the sun, as well as energy transport and the sun's power and rotation. Because of the Earth's eastward rotation, the sun and the planets, the moon, the stars, all rise in the east and set in the west. And on average then, the sun rises at 6 a.m. and sets at 6 p.m. When the sun is halfway between rising and setting, it's at its highest elevation in the sky. It crosses a north-south line, we call a meridian, and this is called a transit. So the sun at its highest point in the sky is a transit. Now, to determine this transit altitude or height, you can Google it probably from your location, or you can determine it the altitude of the sun at noontime using some basic equations. Now, the simplest one is to determine the altitude of the noontime sun on the day of the equinox, and that is simply 90 degrees minus your latitude. Now, in the northern hemisphere, it's easy to know your latitude. You measure the altitude of the North Star, the North Celestial Pole, and that equals your latitude. And as an example, for a person living at, say, latitude 40 degrees north, the noontime altitude of the sun on the date of an equinox then is 90 minus 40, or 50 degrees. And you can simply then add or subtract 23.5 degrees to determine the altitude of the sun on the two solstices. Another example is if you're living at 30 degrees south latitude, the noontime altitude of the sun on the date of an equinox then is 90 minus a negative 30, southern latitudes are negative, which then becomes 120 degrees. Since altitudes cannot exceed 90 degrees, we must subtract that answer from 180 to get the correct answer. So if you live at 30 degrees south latitude, then the altitude of the sun on the date of an equinox is then 180 minus 120, or 60 degrees. This is a table showing you some basic properties of the sun: the distance, the size of the sun relative to the Earth, the mass, the average density, the composition, and in particular the amount of hydrogen and helium by mass. You see is 73%, 25%. Sometimes you'll also see that referenced the composition by the number of atoms. So 91% hydrogen and 9% helium by the number of atoms. These two are saying the same thing, and you see a very, very small percentage of the other elements. This shows you a scale drawing of the sun's size compared with the major planets, and you see the sun is about 109 times the diameter of the Earth. The sun's luminosity, which is the total energy emitted at all wavelengths, you see is 4 times 10 to the 26 joules every second. So an incredibly large number. A joule per second is also a watt. This energy is radiated outward in a spherical pattern, and by the time it reaches the Earth, the intensity of the radiation received at the Earth, you see, is about 1,360 watts for every square meter, and that would be at the equator. This is a brief review of the mechanisms of energy transport. The second law of thermodynamics tells us that the heat flows from hotter objects to cooler ones. Conduction then is energy transported by contact in solids or liquids. And this is not an important process in stars. Convection, on the other hand, causes the transfer of heat from the mixing of gases, because hotter gas is less dense than cooler gas. So like a pot of boiling water, the movement is caused from heated material rising to the surface and then cooling off at the surface to sink back down under the influence of gravity to be reheated. This is important for the interiors of stars, and this is an energy transport mechanism. Radiation is the energy flow from electromagnetic waves, and it is very important in the interior of stars, and also the way the energy from the stars is carried away from the surface out to, in our case, out to the planets. Note that the solar wind also carries away some energy, and also subatomic particles called neutrinos also carry away a lot of the energy from the sun, which deals with nuclear processes, which we'll talk about later. First demonstrated by Galileo in about 1612 by observing sunspot motions over many days, we know the sun rotates, and you see that in this little movie here, the sunspots moving around the sun. The data, the multiple images from 1947, there you see the sunspots moving, and by doing that you can estimate the rotation of the sun, which is about a month. Now modern measurements tells us that the sun rotates what we say differentially, which means it's rotating because it's a gas body. It does not rotate like a solid object. It rotates faster at the equator, taking about 25 days, and more slowly near the poles, about 35 days. The sun's composition can be determined by the spectrum. And what you see here is the visible solar spectrum, also called the Fraunhofer lines. And the spectral lines identify the types of atoms and molecules that make up the gas in the sun. And this shows you that the composition of the sun is about 91% hydrogen by number and about 9% helium, and less than 1% of heavier elements like iron, sodium, calcium, and magnesium. Note that the molecular oxygen lines, the O2 lines, come from absorption by the Earth's atmosphere. This obviously taken from a ground-based telescope. This is a cutaway diagram showing you the various layers and structure of the sun, which we'll talk about more next time, but you see the various layers showing you the interior, consisting of the core and energy transport regions, the radiation zone and the convection zone. The surface of the sun is the photosphere, and then above the photosphere, the atmospheric layers are the chromosphere, transition zone, and the corona. And the corona is the vast outer layer which becomes the solar wind of charged particles leaving the sun. Here is a list of resources, good resources about the sun, and feel free to look at those for more information. Thank you for your attention. Now you're ready to study the sun's interior.